demonstration and coming up, and I'm excited to know a little bit more about this autonomous snowplow. I'm sure that north of here, where they got dumped on a lot of snow, they probably could have utilized that this morning. But we have Andy Narsvin with Thundarr here to talk a little bit about this invention that is pretty interesting. You know, I think as we've all heard and seen some of the things that are happening in the industry today about all the autonomous vehicles, we know that there's an autonomous tractor. In fact, we try to get those guys to come here and demonstrate that as well. But coming from the northern regions of the country, snowplows are a very useful tool for us, and I'm excited to hear a little bit more about this technology. So Andy, if you want to come up, he's got a little PowerPoint, and then we'll do a little demonstration here as well. I know the surface isn't as good as you'd like it, but we'll make it work. So let's give Andy a hand here. Thank you.
Thank you. And I'm actually going to have my friend Tyler Peterson give a little bit of the introduction to begin with. But we're both from NDSU, both going for our master's in mechanical engineering, and we're a part of the Bison robotics team. So Tyler will start us off.
Hi, I'm Tyler Peterson here with Andy. He's going to talk about the plow in a few minutes, but I was going to talk a little bit about our robotics club and what we're up to at NDSU, promoting robotics and eventually autonomous systems. We have a team that participates in competitive and service projects of about 20 to 30, mostly freshmen and sophomores at North Dakota State University. And the goal of our team is to promote robotics on the university campus through a series of competitions throughout the year, and to help university students to promote robotics at high schools through first and best robotics competitions, because all the research and the work that student teams do contributes enormously to the eventual development of autonomous systems, which is why we're here. Currently, Andy's working on the autonomous snowplow. The team is developing designs for a robotic mining competition, and two of the teammates have NASA fellowships this summer to develop software for autonomous navigation using vision systems and potentially lasers. And we're working on developing systems using that same technology on quadcopters. We also have a large group doing volunteer activities through the first and best robotic competitions, which are competitions that high schoolers enter into to build robots that compete in arenas to achieve various goals, like collecting trash as if they're like controlling litter in a real world environment, and they do it competitively. That's you. Yep. Thank you.
All right. And so for our snowplow, we're at a little bit different point than the RDO guys were at. We're just getting on the research side, seeing what we can do for the autonomous snowplow. And for our research, we had 4 main objectives. First, we want to take and get a good dynamic modeling idea of what's going on with the skid steer. With skid steer, you obviously have friction going on that can cause lots of different problems, and we want to find a good way to model all those dynamics and handle everything in an accurate and precise way, because this is a big robot and we don't want it going out of control. So first we had to look at the dynamics, get a good model of what's going on, and then we wanted to look at our sensors. Obviously we can use very high cost GPS and IMU sensors to know exactly where our robot is, but for commercial applications we wanted to reduce those costs. So right now the GPS units we have on there are actually around $80, and then the IMUs I think are around $15. So very low cost sensors, and then the microcontrollers themselves, they're $20 I think. So right around in there. So we wanted to use low cost sensors. The problem with that is your accuracy goes out the window. So finding ways to filter all that and use all that information and still be able to control the robot. And so we want to take our dynamic model information about our sensors and use it in our algorithm and test it out on our robot and see how well it does. So that was a bit of our objectives. We were able to get through, we built the whole system, designed it, and we're still working on the filtering of the sensors right now, but we have a basis of the control algorithm. We can get it to go in straight lines by itself, do 180 and come back, but doing curved linear paths is what we're working on trying to do better there. More about the vehicle itself. It's got two large 24-volt DC motors, one for the right side wheels, one for the left side wheels, and a 20-to-1 drive reduction. So there's a couple of gearboxes in there and some chain reductions to kind of harness all the power that our motors are putting out. And then for our plow, we have a winch to raise and lower the blade and a linear actuator. And eventually the goal is, with the linear actuator, if our plow keeps on going and it gets stuck, there's too much snow, the wheels start spinning, it can back up, change the angle of the blade, and start pushing less snow as the snow gets steeper. Right now we designed it to be able to handle about 2 to 3 inches of snow. So if you have a large snowstorm where you're getting more than 2 to 3 inches, you might want to have it go out and do a few passes as the snow comes down. That's our sensor board that we designed, and with the microcontrollers on there, you can see the GPS units are up there in red. We have our IMUs on there, and what we're trying to find is our position, velocity, and heading angle with our GPS, IMUs, and encoders. And just a little mock-up, the sensors are mounted towards the front in the center of the vehicle, with the exception of the encoders, which are down by the wheels. And then with all that information, it does waypoint navigation, similar to what the drone was doing before. You select your waypoints of your driveway and say, I want it to go down this way, turn around, come back. You can do a driveway, a sidewalk. It's pretty flexible as far as different plow paths. Once we get all the algorithms completed, the hope is to have a flexible system of just select the waypoints with your GPS receiver and tell the robot to go. So with that, are there any questions? Yeah. Yeah, so we don't have an actual charging station yet, but with the path, you'll select your garage or your home point. It'll go through the path and come back home to where you wanted it originally. Yeah. Oh, Thundarr. Possibly. We might have to change it, but I didn't go over. It's actually an acronym. It stands for Terrestrial High-Powered Ubiquitous Navigation-Driven Autonomous Robot. Oh, Thundarr Snow, yeah. Then you don't run into all the copyright infringement with the NDSU bison. My goal, personally, no. As far as the club's concerned, we might get involved with one of the business clubs, who knows, and take our idea to market. If someone's interested in working with our club too, I'm sure they'd be open to seeing where we could go with this. There's definitely a few features that we could polish up and make it so it's more user-friendly than it is right now. But like I said, it's all in the development stage, trying to make it work well. I'm actually finishing up my master's, and so I've been working on trying to do the dynamic modeling and controls for the past 2 years. It was built, I didn't actually build the actual robot itself. I've been looking into the controls, but it was built the year before I started my studies. So this robot itself has been worked on for the past 3 years by various groups at NDSU. So, yes. Oh yeah, Pastor. Someone suggested earlier put the seat on and use the horns to control it, move back and forth. But, yeah. We aren't, partly because we actually run in a competition too. Every year in downtown St. Paul, there's an autonomous snowplow competition put on by the Institute of Navigation, and part of their regulations just have a blade on the front. But once you solve the navigation problems, switching out what you have in front isn't a huge issue. So. That's another thing that comes with the regulations. like I said, it runs in downtown St. Paul, and they have some nice brick roadways that they don't want us to wreck. So, but yeah, you could put studded tires on there, put tracks. Tracks has a little bit different dynamics. You'll have to do a little bit different considerations with the controls, but yeah. This year there are 8 different snowplows, and we placed about 5th. So we're still working our way up on our control algorithm, but we have more power than everyone else because we're all mechanical engineers. We said we'd make it as big as we could. Everyone else, most of the other groups are electrical engineers, and they're all into the computer control side, but sometimes they lack power. So. Yep. Yeah. We haven't done a full life cycle test, but based on our initial calculations, we wanted around an hour before we'd have to charge it again. And that's based on, depends on how much snow you're pushing, how many times you turn the motor, because it requires a lot of torque to turn the skid steer. So that'll drain your battery faster than going straight. But so different factors like that. But we're hoping with these batteries we can run easily on for an hour. But yeah. Oh yeah, yeah, we'd run over all of them. Yep. Yeah, you just take your GPS receiver, plug in the points, the waypoints you want it to hit, and then it'd go around your sidewalk or your driveway and clear all your snow for you. Yep, drinking your coffee, watch it go. You don't even have to use the remote control, you can just watch it. So. And as North Dakota, you don't always need a storm to cover your snowplow or your snow driveway with snow. The wind will blow it back on for you after you're done. So set it to go periodically throughout the day if you have that problem. Yeah. Yes. We don't have it right now, but like I said, we're working on the controls right now. As we get the controls hammered out, we can work on different features, making it dock. Someone said take the tail and make it a plug-in so you can plug it into the wall. Yeah, so, but yeah, that eventually as the technology develops, make it dock, have a little station in your garage, dock it, let it charge, and then as the snow falls, bring it out again. Oh yeah, yeah, put it in the doghouse. Might get some competition with the dog, but. Yeah. Yep. Yep. What am I planning on leaving for them? Yeah, so I've actually graduated. I just finished up, and I'll be involved with finishing up some of the control algorithm as well, just because I want to see it finished. This robot itself will remain relatively untouched. It'll go into the control of the robotics club, and if they want to tweak things and test things different out, make a docking station or whatever, they can do that. NDSU itself, we have senior design teams that come and do different mechanical designs. And one of the things they do, they try and do different steering mechanisms for the plow itself. Like last year, we tried out an articulated steering design. We had some problems with the weight distribution. It didn't steer all that well, but we're always trying to find new ways to steer, which ways to work better for plowing, and different things like that. But, yeah, and then if we get a good steering model, another master student will come in and do the controls. And so. That's kind of the model we have set up for this project anyway. Yep. Yeah. Yeah. Yeah, we need Google to come and give us their nice cameras and laser sensors. Yeah, I'll try and see how much it can turn on here. It hops a little on this rough surface, but we'll see how well it goes.
What about, is all this equipment off the shelf?
So we took different off-the-shelf components like our IMUs, our encoders, and our GPS units. They're all off the shelf. But if you take a look at our circuit board, I forget which. That circuit board we designed in-house, made it so it fits all the different sensors and the microcontrollers. And then the body was all custom built. The wheels were put together, put on there. Those are just regular trailer tire wheels you can get. And then, yeah, mostly everything was designed by us and put together from individual components. The back is slightly heavier, but because we have the plow on, we have all the batteries in the back. So there's 5 12-volt batteries on there right now, actually, just because we can. It's big enough to put all that on there. And then the plow on front kind of balances that out, but most of the weight is still focused in the back. The DC motors and the gear reduction are towards the middle of the robot. But yeah, that helps evenly distribute between each tire. We haven't looked into that too much just because we hadn't had problem pushing the snow in the competition, how much they had. We could maybe increase it so we could push, 4 to 5 inches if we change the weight distribution out a little around. But, yeah.
Also, you mentioned that, one of the other things you could do is either put a snowblower on there or a brush as well, so you could have those other attachments. I'm sure you've thought about that as well.
At the competition, actually, there was a team from Canada. They just wanted to build the snowplow on their own and didn't know about the competition. And they originally designed it with a brush. And they had to switch out their implementation for the competition. But yeah, it's put different attachments on there. Might not work too well for lawn mowing, but just because it's skid steer, you don't want to tear up your grass. But
Maybe for rotor tilling. Huh?
yeah, there you go, rotor tilling. Yeah, yeah, yeah. Oh yeah, just on style points alone.
Well, any other questions? Well, let's give them a hand. Thank you very much for coming all the way from Fargo to show off what you guys are doing. It's great to see the technology and students and what they're doing in their college classes.